Survey of Infrastructure Attacks Part 2. Let's just go ahead and take up right where we left off in the previous nugget. We looked at denial of service attacks and distributed DOS attacks, as well as talking about other availability attacks. Let's just move right into this next column here. In this nugget, we're going to look at domain name kiting. We'll look at the concept of DNS poisoning, ARP poisoning, the address resolution protocol. We'll look at weak passwords, and I'll give you some strong password recommendations and some methodologies to use there. We'll look at backdoors. I've already mentioned backdoors, but we'll kind of break those down again. And then finally, we'll talk about default accounts. Here's an interesting little vulnerability and kind of a new buzzword, actually. It hasn't been around long. Concept of domain kiting or domain name kiting was actually coined by the president of GoDaddy.com, famous for their Super Bowl commercials, and Bob Parsons kind of came up with this little buzzword. This is a scam that is not really necessarily illegal, but it involves leveraging and taking advantages of some weaknesses in kind of the domain naming registration and re-registration process. There's a few large domain name registrars out there, and they will purchase huge numbers of well-indexed, well-exposed, expired domains. And then they'll throw up these temporary websites that will host these expired domains. And then what they do, and I'm almost positive you've seen these yourselves as you've surfed the web. If you, for example, you type in a particular domain name incorrectly, like maybe one letter is left off, and you don't end up going to the actual site you wanted to go to, you'll see one of these kited sites, and they're loaded up with advertisements and paid links that get redirected via search engines like Google and Yahoo. And what these people do is they buy these up, they throw advertisements on there, and they kind of end up getting free advertisement because there's a 5-day grace period built into registering domain names where you can get a full refund before this 5-day grace period. So what they do is they register these expired domains, and then they load them up with advertisements. They get free advertising redirected by search engines, and then they drop them before the 5-day grace period. What they'll end up doing is they just keep doing this over and over and over again. So a perfectly legitimate domain name might get kind of trapped in like this vicious cycle of domain kiting schemes. So they'll never be available to the public because they just keep going through this process over and over and over again. At this point in time, the organization responsible for registering domain names is ICANN, ICANN. Presently, at this recording, they allow this practice, but this is a new buzzword. It's a term that CompTIA wants you to know about on the Security Plus exam, domain name kiting. The next couple of topics relate to DNS, domain name system poisoning, and ARP cache poisoning, the address resolution protocol. And ARP operates basically between layer 2 and layer 3 of the OSI model, DNS at the application layer. So the point I'm getting at here is that there's poisoning that goes on at all different layers of the OSI model of the TCP/IP stack. Basically, this is just taking information, buffers in memory, caches in memory, and just filling them with bad information, either by redirection, by inputting bad information, a wide variety of methodologies. You can poison the ARP cache on a server or a workstation. You can poison the CAM tables on switches. You can poison routing tables with dynamic routing protocols, for example, like RIP version 2. And OSPF. You can poison those dynamic routing protocols and the information that they share with one another. And of course, we can also have poisoning of the DNS name service. So understand that the concept of poisoning really just comes down to different kinds of attacks on protocols and services that are typically TCP/IP based that have the dynamic sharing of information as well as information that's stored in memory buffers or caches that are used on behalf of those particular devices and clients. And by inputting bad information, you can cause a wide variety of problems as well as redirecting users and data to nefarious or malicious sites or servers. So we're going to look first of all here at the concept of DNS poisoning, which has been around since the beginning of the domain name service. Actually, this problem was much more prevalent early on, but it still kind of exists, so we need to talk about it. Now let me say right off the bat, with DNS poisoning, this can be structured or unstructured. What I mean is it can be malicious, intentional, or it can actually be unintentional. The bottom line is it's data that's given to a DNS server that didn't originate from an authoritative DNS source. Again, DNS poisoning, also referred to as DNS cache poisoning. A lot of things can cause this. It can be maliciously prepared attacks by malicious users. It can be bad software code. It could be just misconfiguration of DNS servers. Several things. Bottom line is, once the DNS server gets such non-authentic data and it stores it up, caches it for future use, it's poisoned and it supplies non-authentic data to its clients. Not a good situation. Attackers will use cache poisoning attacks to exploit flaws in the DNS software that allow it to accept incorrect information. For instance, an attacker will poison the IP address DNS entries for a target website on a specific DNS server and replace it with the IP address of a server that he or she is in control of. Then they create fake entries for the files on the server that they control with names that match those on the target server. And this could contain malware, worms, virus, malicious content, all types of things. That's the poison, okay? Now there's really three main types of DNS poisoning attacks. There's one where a malicious user redirects the name server of the attacking domain to the target domain, the name server of the target. Then it assigns that name server an IP address that they want to specify. A second method involves redirecting the name server of another unassociated or unrelated domain to the original request to an IP address specified by the attacker. And then the third one is called DNS forgery. And this means pretty much beating the real response to the punch. In other words, it returns the recursive DNS query back to the DNS server in a forged fashion before the real DNS server does it. Most of these can be fixed now with just basic changes in making the DNS methodologies. For example, Microsoft's Server 2003 has functionality built in to stop this by integrating DNS with Active Directory and its secure updates. Other newer versions of Bind, for example, can do this. There's also a secure version of DNS called DNS SEC, which, SEC, let me get the C in there, which uses digital signatures that are signed with a digital certificate to determine the authenticity of the DNS data. Now, another thing I want to talk about here that's kind of related to this is a term that may come up on your Security Plus exam, and that's a term called farming. We've heard of phishing, P-H-I-S-H-I-N-G. Well, how about farming? Farming is also done by exploiting vulnerabilities in DNS server software or changing the host file on a particular victim's computer. The host file was the original basic domain name service. It was a text file that was used early on in the early days of TCP/IP and was later replaced by Berkeley's domain name system. So farming is when a hacker tries to redirect a website's traffic to another bogus website. Compromised DNS servers are often called poison, for example. In January of 2008, the Symantec company reported a pharming incident that was directed against a Mexican bank, where the DNS settings on a customer's home router was changed after receiving an email that appeared to be from a legitimate Spanish language greeting card company. Pharming. Now, next I want to talk about ARP poisoning, Address Resolution Protocol. We know that ARP operates at layer 2 and layer 3. Almost all TCP/IP networking devices have a cache or an area of memory that's used by the ARP protocol to store IP address to MAC address or layer 2 MAC address mappings. I'm going to take advantage of this opportunity to talk about ARP poisoning, to also talk about switch or network switch layer 2 switch security concerns, along with some ways to mitigate against those concerns. So I'm going to kind of kill two birds with one stone here, since we're dealing with the kind of layer 2 vulnerabilities. Let's do a little refresher course with the way the ARP protocol works real quick. Over here I've got my host, and we'll call this host A, and it's plugged into the port on some type of layer 2 switch. Not a hub, but we really use switches nowadays. And over here is host B. Now let's say that these devices have just recently come into this switch. This switch doesn't know the MAC addresses of these devices, or let's say it's a hub, however you want to look at it. The way the ARP works is this. Computer A is going to ask the network, hey, who has this IP address? So the request is sent. Computer B is going to respond, you know what, I have that IP address, and by the way, here is my MAC address. Now, by the way, if this is a switch, it's going to learn the information. It's going to put that in its CAM table. Now, a reverse ARP, or RARP, which is also used out there, is the reverse of the process. Okay, that's why it's called reverse ARP. Okay, computer A asks, who has this MAC address? And computer B says, hey, I have that MAC address. My IP address is whatever, 209.5.5.1. Now, all the devices, as I mentioned, have an ARP table. It's a cache, short-term memory of all of these IP addresses and MAC address mappings that kind of go together so it can have easy communications from here on out. The problem is ARP doesn't have any kind of device authentication method. There's nothing built in. So it's a very trusting, very gullible protocol. So you're the malicious hacker, and you realize that the ARP protocol doesn't have a way of verifying the ARP replies. And you've also learned that lots of devices will accept ARP replies before they even request them. So what if you went ahead and crafted a valid yet malicious ARP reply that had an arbitrary IP and MAC address of your choosing? So you can easily, if you're a malicious attacker, poison this MAC address table or MAC cache on a switch or on a server or on a client workstation with very simple tools that script kiddies can download off the internet. Now, this behavior of ARP can also be used for denial of service attacks, because you can flood internetwork devices with tons of made up or spoofed MAC addresses. So you can basically flood these CAM tables or these ARP caches with a ton of MAC entries. So ARP poisoning can poison the actual information stored in those caches, but it can also be used to fill up those caches in a form of denial of service attacks. This can pretty much bring down a small network. In a large network, it can basically really cut into the overall effective bandwidth, and it can really slow down processing on switches and servers and routers. Remember, routers, even though they operate at layer 3, they also do switching as well. They also do ARP. So ARP poisoning, along with DNS poisoning, is really just a way to poison those memory areas, those memory buffers that store, in this case, layer 2 MAC address to IP address mappings. Remember, in DNS, we're talking about mappings of friendly names or fully qualified domain names to IP address mappings. Well, the first attack method I've already alluded to, and that is basically flooding that layer 2 device, that switch, with a MAC address flood. using techniques, using software to basically exhaust the caches, the memory, the tables on that particular switch, and then it disallows it from actually doing any valid switching. It'll also start flooding information out all of the ports and bringing the network down. We mitigate against this by using commands on the switch that are called port security, and that basically says, you know what, we're only going to allow a few number of MAC addresses on this port. Maybe one MAC address, maybe 5 MAC addresses. Maybe we'll say, you know what, we're going to statically configure 2 MAC addresses, but we'll allow 2 to be dynamic on that port. So you have all of kind of flexibility there. We also use on these switches things called VLANs, which are virtual local area networks. We just configure on a particular port, for example, these 3 ports here and these 3 ports here and these 3 ports here all belong to the same subnetwork or the same broadcast domain. Let's say they all belong to HR. If this switch is on the 3rd floor and this switch is on the 2nd floor, then we can have HR personnel on both floors, and they're in the same broadcast domain, the same IP subnet, a very common thing to do in an organization. VLANs are vulnerable because they have protocols that kind of trunk these switches together. Those can be exploited too. So VLANs can be hopped. Somebody can hop from one VLAN to another when information is not supposed to go into that broadcast domain. I mentioned there's also spoofing that goes on. Spoofing is masquerading. You can do spoofing attacks to spoof the DHCP protocol that's used on those switches. You can also spoof information in the spanning tree protocol, which provides loop prevention on those switches. Again, we can also spoof MAC addresses. There's protocols that can do that. MACOF, M-A-C-O-F, that can do that. We can also spoof address resolution protocol as well. And again, there's techniques on the switch, like port security, like a thing called DHCP snooping. Did the H first, DHCP snooping, which basically says we're going to listen to ports. Let me make sure I spell that out right. This is supposed to be a P. Snooping. So we're going to listen to the ports, and we'll only allow DHCP servers on this port, and the other ports can't be DHCP servers. So we can't have that spoofing process of someone trying to be a rogue DHCP server and hand out DHCP information. Now, I don't know if you know about DHCP, but it provides more than just IP addresses and subnet masks. As a matter of fact, there's a field in the DHCP header that's 8 bits, and there's actually about 255 different options that can be doled out on behalf of the DHCP server. So this is a lot of information somebody can find out about your network, number one. It's also a lot of information that can be spoofed or phony information injected into your network. Information like, what domain are you in? Who's your mail server? Who's your WINS server? All kinds of information. And of course, there's other protocols as well, like Telnet, that might be used. If you're using Telnet to access that switch, well, Telnet sends information in clear text. So might not want to use Telnet. Might want to use something like Secure Shell and create a Secure Shell VPN tunnel between our client. Maybe we're using PuTTY. Maybe we're using something like TerraTerm and that particular switch. We don't want to be vulnerable to sniffing. So sniffing's bad, spoofing's bad, snooping's good. Okay? Good luck remembering that. Also, a lot of folks will use HTTP protocols, and they will use some kind of graphical user interface to manage this particular switch. Well, this is not secure either. Information sent in clear text. So we want to either not use HTTP on the switch, which is not a bad idea, or use the secure version, HTTPS. So again, along with our discussion of ARP, which is a layer 2 to layer 3 protocol, we're also looking at our primary device that operates at layer 2, and that is the switch. Some switch security issues. Okay, you know what? I want a clean slate here as we talk about different password issues. And we're talking about weak passwords. What are weak passwords? Well, let's say you work for I don't know, CBT Nuggets. Here's a weak password. CBT Nuggets. All right? Here's a weak password. Fluffy. The name of your cat. Okay? Gus. The name of your dog. Gus 2008. The name of your dog. Anything involving the company name, your pet's name, anything that's guessable in the dictionary. Your favorite football team, Dolphins. These are weak passwords. What are strong passwords? And by the way, we're going to enforce these strong passwords using either network operating systems, we're going to use authentication services, we might even use services on networking devices to enforce this. We might even use Active Directory. Here's the deal with the group policy. I'm slipping that in there. ADGP, group policy. Maybe you're not Microsoft. Maybe you're Sun Solaris. Maybe you're Linux. Maybe you're Macintosh. Whatever. There are techniques to enforce strong passwords. What are strong passwords? Well, I'm going to tell you it's going to be 10 or greater characters. It's going to be using all 4 character types: uppercase, lowercase, numbers, and symbols. Okay? Also, if somebody attempts to log in 3 times or 5 times and they're unsuccessful, we are going to lock them out. We're also going to use password history. We're going to make sure that someone doesn't use the same password again for, let's say, 12 to 20 iterations. So if we're saying you have to change your password every 30 to 45 days, you can't use the same password again for 12 iterations or 12 months in this situation, or 12 45-day periods, or 20 45-day periods. This is overcoming weak passwords. Now, the best way to overcome weak passwords is to use what's called pass phrases. For example, you want to think of a phrase that you can easily remember. I like jazz music, specifically jazz from the late 50s and early 60s, so I like John Coltrane. So I might come up with a passphrase that says, I love to hear Coltrane. So I can remember that. It's a phrase I can recollect on a daily standpoint. So I might say, I love to hear, this is 0, C-O-T-R @ symbol, lowercase n. I love to hear Coltrane. Here's the deal. I'm using uppercase letters, I'm using numbers, I'm using lowercase letters, I'm using symbols, the @ symbol. I could sub the 0 for an asterisk symbol. Whatever I need to do. I do not want to write this password down anywhere. No sticky notes on the monitor, no index cards in the top drawer, no scratching it out on a notepad somewhere. I'm going to memorize this. I memorize the passphrase first, which is something I can remember. Things about your music you like, pets you like, family members. A phrase that's 8 words to 10 words that you can remember, and then assign kind of a mnemonic. Okay? Let me write that down. A mnemonic exercise to memorize and have this password represent your passphrase. That is the best technique for overcoming weak passwords and create strong passwords. Without a doubt, as far as access controls are concerned, as far as making your company and your organization vulnerable to many types of attacks, creating strong password policies and enforcing them throughout your entire organization with network operating systems and the techniques built into Microsoft or Linux or Sun Solaris or Unix or whatever are the best ways to overcome weak passwords. You need to know this for your Security Plus exam. As a matter of fact, you need to know everything I'm telling you for your Security Plus exam, but this is really important. You know, recently my in-laws called me over to their house. They were having problems with their computer. Their web browser was acting funny, so I came over and I went up and I ran on their machine Internet Explorer. And one of the problems they were having was, let's say they would go to a search engine like Google. They would go to Google and they would type in a search for something, let's say like, oh, well, our topic right here, backdoors. Then they would go to a link. For example, if we went down here to, let's say, let me here's tech.yahoo.com blogs about BIOS backdoors, getting into the backdoor on a BIOS of an operating system. They would click on the link, and instead of going to this URL here, it would take them to some backdoor. It would redirect them to some other Windows page that had a bunch of advertisements on it. It kind of related to what I talked about earlier with that phenomenon of domain kiting. So this is kind of a combination of domain kiting and farming. And this farming feature that was put on their machine was because they downloaded some Trojan horse or backdoor program from either some website or through some phishing attack in their email when they clicked on a link. And I would go and I would download another browser like Firefox, and the same thing would happen. So that is an example of a backdoor type of Trojan horse program. Now, a lot of other backdoor programs can actually do more than just do redirects. They can actually copy keystrokes. They could do remote control activities. These are programs that have been around for a while, like Sub7, Back Orifice, NetBus, Master's Paradise. These programs get installed typically through some nefarious Trojan horse program, and it would allow a malicious user to basically get unauthorized remote access to the system. Not always remote access, but access to the system. Once that program's on the system, the attacker can then steal data. They can do damage to files and other system areas and applications. They can escalate their privileges, or they can deploy other programs. They can use the backdoor code to actually deploy other programs, maybe to launch a distributed denial of service attack or drop a logic bomb on there, or other types of programs like the ones I mentioned that redirect searches to advertising pages away from the results of your search. Besides being planted and used with Trojan horses, backdoor programs can also come from freeware that you download and shareware that you download. Those peer-to-peer file sharing programs that were so popular and are still popular, peer-to-peer file sharing like Morpheus and Kazaa and eDonkey and all those other ones, those also can install not just adware and spyware, but they can also drop backdoor programs onto your system. And they can also be accessed through phishing and email and farming, being redirected to web pages. Now, another thing about a backdoor that's also maybe mentioned in the Security Plus exam is backdoors can also be code that's written into, I'm going to just drop this down here, put another bullet point, code that's written into a program. So the actual developer themselves, the application developer, the programmer, may also have code into the program which is a backdoor that they can use that only they know about, and they can use this backdoor as at a later date to actually get back into the program. I don't know if you've seen some of those shows on television about people who would, trick casinos. Some of the biggest exploits and heists on, let's say, slot machines were the people that were actually developing the chipsets and some of the code on those slot machines. They would put a backdoor program in there, and they would hire some dupe person or get someone to join their team, and they would have like a certain sequence that you would put in the slot machine, and it would pay off. I think they did something similar to that on the movie Ocean's 13, I think, as well. So anyway, backdoors can be a wide variety of things, and lots of different techniques are used to put backdoors onto operating systems, to server systems, workstations, and the like. Now, the final infrastructure attack we're going to look at here in part 2 is the vulnerability of default accounts. And let me tell you something, there's default accounts on everything. A lot of times Microsoft Windows gets kind of a bad rap for some of their default accounts, their built-in accounts. For example, they've got accounts called local system, which is, kind of a local system, which is kind of a pseudo account because users can't log on to a computer as the local system account, but certain applications and processes can log on using this account, for example, in Windows 2000. So those kind of local system accounts, other built-in accounts like IUSR, Internet User Host, that's kind of a new account, IWAM host, and if you add new applications to your operating system, that may give you default accounts. We're talking about default system accounts, the guest account, and all different types of systems have default accounts, and along with those default accounts often come vulnerabilities. Now, why do we have these default accounts? Well, because you want your programs and your systems to be functional, and a lot of times vendors will sell programs and hardware, and they want it to be functional out of the box. So it will have basic default functionality, and a lot of times that default behavior of the operating system or the telephony application or the wireless access point has default accounts, default settings that create vulnerabilities. On my system here, for example, if I go, let's take a look at settings, control panel. If I go to my Vista machine and I go to user accounts, here's my account. I'm the administrator. It's password protected. It's a very strong password, by the way. It's, I think, 12 characters, 12 characters with 4 different types. But I can manage another account. You can see on my Vista system here that there is a guest account, but by default, the guest account is off. So the default behavior of Vista is that the guest account is off. This hasn't always been the case for operating systems down through the decades. So you've got these guest accounts, you've got these basic user accounts, you've got system accounts. We call this a predefined user account, by the way, guest. The administrator account is also what we would call a default account. And the administrator account, by the way, is one you want to really be careful with. And let's just talk about this as we finish up this nugget. Let's talk about this administrator account. Here's some things you don't want to do. You do not want to have, I'm going to put no, you don't want to share the admin account throughout your networking environment. I've seen this before in the past doing troubleshooting or doing consulting. Is a small to medium-sized business will have several users sharing the administrator account. Also, what you'll see done is you don't want to use the same password, and often it's a weak password like the company name. You don't want to use the same password for multiple accounts, especially multiple administrator accounts. What we really want to do is we want each user to log in or log on with a basic user account. So you want to log on as a basic user that just has fundamental access and rights to the systems. And then, when they need to do activities or run programs that need escalated privileges, they will do what's called run as. They will right-click, for example, and they will choose the run as command, and they will say, you know what, we're going to run this as, and then they'll type in the credentials for the administrator. They'll do their activities, they'll do their processes, run their program, and then they'll get out, they'll log off as the admin user, and then go back to that basic user account. Sometimes individuals will rename the administrator account. Okay, they'll rename it. They'll use that renamed account as the admin account, and they'll actually then they'll actually create another account called administrator with just basic user rights, and then maybe they'll audit that account. So if somebody tries to come in, even one of the other administrators, and use that account access, they can audit that, and it'll show up in their logs, and they can kind of, trick their own employees that way. Something else you don't want to do is this. A lot of times, I mentioned those system accounts, local system accounts, other system accounts. When you install applications like, let's say, SQL or maybe Exchange, things like that, you will install these using some type of special account for that program or a system account. Something you don't want to do is you don't want to install in a production environment these extra add-on applications or services under the auspices or under the account of the administrator account. You want to use some separate account. Exchange admin, SQL admin, create some new account with its own privileges. And again, we're going to look at access controls here coming up in a nugget after this, but this default account vulnerability is just one that's been added to the list in this particular domain of Security Plus. So you need to know about that, and this is rampant, it's widespread, it's really not vendor specific. All different vendors, all different types of systems and services and applications have some type of default account, and there's some level of vulnerability in most of these systems. Excellent. Alrighty, well that wraps up Infrastructure Attacks Survey Part 2. In Part 1, the previous nugget, we looked at legacy protocols, TCP/IP hijacking, null sessions, spoofing, man-in-the-middle attacks, replay attacks, availability attacks like denial of service and distributed denial of service attacks. Looked at domain name kiting first off in this nugget, DNS poisoning, ARP poisoning. There's all kinds of poisoning and all kinds of different poisoned systems. Looked at weak passwords and how to create strong passwords. Talked about backdoors, which is also related to Trojan horses and other types of spyware and adware, also phishing and farming, and then finally, attack on your infrastructure using default accounts. I hope this CBT Nugget's been informative for you. I want to thank you for viewing. We'll see you in the next nugget.